All right, before we jump into independent and dependent quantities, we need a quick little recap on our coordinate plane and the different parts of our coordinate plane. So I just have quadrant 1 right here. We'll say that my x values are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So again, because I have everything positive, this would be quadrant 1 or Q1. So remember, my axis that runs horizontal from left to right is my x-axis. My axis that runs up and down or vertically is my y-axis. And the place that they intersect is the origin. Now remember, the origin is 0.00. So if we wanted to graph the point for 2, remember the first number in an ordered pair is always your x-axis. So since it's positive, I'm going to start at the origin and move to the right 4 spaces. Then from that new spot, I'm going to move up 2 spaces. So I would have put a dot right there. Now, a graph is a great way to show ordered pairs, but they're not our only way to show ordered pairs. We can also use tables to show ordered pairs as well. But just like we talk about our x and our y, those are the official names of this axis. But when we start changing representation, so from a table to a graph, I don't have an x and a y axis on a table, right? It's not a graph. I can't call them an x and a y, but they do represent parts of our graph. So we're going to look at what are some other words that we can use for our x and our y axis. So that way it just kind of helps us keep it all kind of together when we switch representations. So one way you're going to hear is input, output. So our tables are also called input-output tables. So you're going to put something into the table. There's going to be a process, there's going to be a change, and you get another number as a result. So the input is the x. It's always what you're starting with. X is going to go through some process, some change, and out is going to come your y value. So input is x, output is y. To bring in some ELA terms, it's like our input is the cause and the output is the effect. So X causes Y to happen. Or the X is the independent variable and the Y is the dependent variable. So no matter what words you use, X is always the start, Y is always the end. So you could see this written a few other ways. We could see whatever we have for X causes or determines whatever your Y is. And then the other way around, we could see that Y depends on X. So let's look at this in an example so we can start using some real life situations for these words of cause, effect, independent, dependent. So our first group here, it looks like I've got this table over here, and the title of my table is dog medicine. And that's really important. You always want to pay attention to what is your table talking about. So it looks like one column is the weight of your dog in pounds, and the other column is the amount of medication, but in grams. So I need to figure out which one is the independent, which one is the dependent, which one is X, which one is Y. So I just kind of use these interchangeably, and I'm going to use these sentences up here. So if I'm trying to figure out what the X value is, so I could say that X causes Y, or X determines Y. So I could say that the weight of the dog determines the amount of medication. And when I look, it looks like a 6-pound dog gets 3 grams of medicine. An 8-pound dog gets 4 grams of medicine. A 10-pound dog, 5 grams of medicine. And a 12-pound dog, 6 grams of medicine. So my dog, however much it weighs, that changes or causes the amount of medication that they get. So that sounds like it makes sense, but I'm going to try it the opposite way just to really make sure. So what if I said the amount of medication determines the weight of my dog? So is the medication going to change their weight? that really doesn't make sense. But the weight of the dog would change the amount of medication that they have. So the weight of my dog, that is my x-axis, my x value. The amount of medication is my y-axis, or my y values. So this means the weight of my dog is the independent variable, right? It exists on its own. Not every dog has to take medication, but every dog is going to weigh something. And then the y value, the amount of medication, is the dependent. Okay. If I look over here on my graph, they were actually so nice to already label our x and our y axis for us. So it looks like we've got it right. The weight of the dog is my x. The amount of medication is the y. Let's go ahead and label this as independent and dependent. So again, my x is the independent, my y is the dependent. And it also wants us to plot the ordered pairs. So I'm going to start with my first pair. It's 6, 3. So again, I'm going to start at the origin. Since it's a positive 6, I move to the right 6, and then up 3. And then I put a dot. Our next one is if my dog weighs 8 pounds, it's going to get 4 grams of medication. So my x is 8, move all the way up to my y is 4. My next one, if my dog weighs 10 pounds, it's going to get 5 grams of medication. So x is 10, y is 5. And our next one, if my dog weighs 12 pounds, it's going to get 6 grams of medication. So x is 12, y is 6. Now, the reason we want to plot these on the graph, and I'm going to switch to my pencil here for a second, is because I can actually connect these dots, and it's going to give me a pretty good idea of how much medication my dog would weigh, or my dog would get if it weighed different amounts. So I'm just going to grab my star chart here because it's the closest thing to me. And I'm going to connect those lines, or those dots, all the way down to the origin. There we go. So again, this kind of gives me a good idea. If my dog weighs 4 pounds, it's going to get about 2 grams of medication. If my dog weighs 14 pounds, it's going to get about 7 grams of medication. So it can help us predict other data points from that table. All right, let's look at our next one. Our next one says the graph shows the relationship between X, the number of weeks money was put into savings. So sure enough, down here, they've already got our X-axis labeled as the number of weeks, and Y, the amount of money that was put into the bank. So this one says list the independent quantities represented on the graph. So if it's independent, remember those are my X values. So I have X values of 1, 2, 3, and 4. Now, 0 and 5 are on my x-axis, but they don't have a dot that is using that x coordinate. So I do not include 0 and 5. So my independent quantities are just 1, 2, 3, and 4. So for my dependent quantities, that's my y. So it looks like I have one at 11, at 12, 13, 14. So again, I might see numbers on my y-axis 0 through 20, but the only ones that have a dot plotted at that y-coordinate are 11, 12, 13, and 14. So again, biggest takeaway from here. Input, cause, and independent are all about your x-axis. Output, effect, dependent are all about your y-axis. Your x will cause or determine the y, and the y depends on x.